So what we have done in the last lecture, we just revised the things. So we have seen some properties of eigenvalues and eigenvector of a square matrix, and how one can find the eigenvalues and eigenvector. Suppose I have a matrix A, then we can write down a non-zero vector x such that ax is equal to lambda x. So this is nothing but what we have our important equation. Now from that equation, you can calculate simply a minus lambda I operated on x, which is equal to 0. Here A is the matrix, lambda is nothing but some scalar, I is nothing but some identity matrix, and x is nothing but your eigenvector. Okay, and for finding eigenvalue, you have characteristic polynomial. Can someone tell me what is my characteristic polynomial here? Determinant of
a minus lambda I.
A minus lambda I is equal to 0. And after solving this, you will get, and roots of that polynomial are nothing but are your eigenvalues. That is the first important way to find the eigenvalues. And for finding eigenvector, you can go with that double star equation. What you are going to do? So you will get a different eigenvalues. For different eigenvalues, you have corresponding different eigenvector. So you just substitute the value of lambda in the equation double star, and you can find a homogeneous system. And the solution of that homogeneous system is nothing but your eigenvector. Keep that thing in your mind. Eigenvector is always non-zero. Always non-zero. Okay. So this is what you have for the eigenvalues and eigenvector. So let's see some examples. So before going to start with the example, let's write down the remark. Write down everyone with me. So let A be a 3 cross 3 matrix. Then its characteristic equation is, so we have directly, if your A is 3 cross 3 matrix, then you have directly a characteristic equation. Lambda cube, lambda is nothing, you know what is that lambda. Lambda is nothing but your eigenvalue. So lambda cube, we have initially plus sign, then minus s1 lambda square plus s2 lambda, again minus determinant of A, which is equal to 0, where S1 is nothing but trace of A. What is trace of A? What is trace of A? What is mean by trace? Trace of a square matrix. Sum of diagonal elements. Correct. Yes, sum of diagonal elements. Okay, your S2, that is nothing but this value. S2 is nothing but sum of minors of diagonal element. So while solving the example, I will explain that. Everyone knows how to find the minor. So once you find all the diagonal minor, you have to add them. You have to find the sum of that value, and this is nothing but your S2. And last is nothing but determinant of P. That is, you know how to calculate the determinant of it. Everyone understand that?
Yes, sir.
Okay. Now let's see some example. While solving the example, you will get a more clear idea about that. So please write down this thing first, then we will go for the example. Once you're done with that, please tell me.
Done, sir.
Okay. So write down the question.
So 1 minute.
Okay. 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 Done it.
Yes, sir. Done.
Okay. So we have question. So in your examination also such kind of question we may ask. So question 1, what they are saying, find eigenvalues. Find eigenvalues and eigenvector corresponding to lowest or smallest eigenvalue. Okay, of a matrix A. So matrix A is given to you 5 minus 10 minus 5. Next is 2, 14, 2 and minus 4, minus 8, 6. Okay, now see what we have. What we have here. Don't write down here. That part please don't write down. Huh? Revision. So just understand, we are not going to solve this problem by using this method. What we have a method, you have characteristic polynomial is equal to a determinant of a minus lambda I, which is equal to 0. So what you are getting, determinant of a minus lambda I. A is nothing but this matrix, I is nothing but the identity matrix, lambda I is nothing but all diagonal elements are lambda, 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 and other elements are 0. Am I correct? If I find out lambda I, what I am getting, lambda I, lambda into I am getting this matrix, lambda 0 0 0 lambda 0 and 0 0 lambda. Yes or no?
Yes, sir.
Now this only lambda 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 I am going to subtract from the A. Okay, so what I am getting, 5 minus lambda, then minus 10 minus 5, again 2, 14 minus lambda, and again 2, again minus 4, minus 8, 6 minus lambda, and find out this determinant and you will get the equation. This is what we have the way, but solving this determinant, it is time consuming. It will take lots of calculation. Instead of doing this, what I'm going to do, I'm going to use this remark. What is that remark? If A is 3 cross 3 matrix, then we have directly, this is nothing but our characteristic equation. Okay, or characteristic polynomial. Okay, so this is directly I have, just I need to find the value of S1, S2 and S3. So can someone tell me what is value of S1 here?
25.
Very good. Now determinant of A you can calculate, and S2 we can calculate this. So let's see. So don't go this method. This is also the correct one, but it is time consuming. This is time consuming method. Okay, this is our usual method, but it is time consuming. So we are not going to use this one. Okay, so we directly write down, we have characteristic equation. So for 3 by 3 matrix, always this is characteristic equation. Lambda cube minus S1 lambda square plus S2 lambda minus determinant of A, which is equal to 0. So S1 we know the trace of A. So trace is nothing but 5 plus 14 plus 6. You are getting 25. Now S2 is nothing but, what is S2? Sum of the minors. See here, sum of minors of diagonal elements. So whatever we have diagonal elements, we need to find out its minor and we have to add them. So let's find out What is the minor of 5? Can someone tell me? Minor of 5?
2 minus 8.
Yes.
6.
So what you need to do, delete this particular row and that particular column where that 5 appears. So delete first row and first column, whatever remain, just find out the determinant of that. So this is our first problem. That's why I write down this one. Otherwise, you can directly calculate this value. So this is the first diagonal element. What about second diagonal element? That is nothing but the 14. So what will be its minor?
5 minus 5 minus 4. 6.
Very good. Minus 4 and lastly 6. Am I correct? And again the minor of 6. Again third row, third column. So you will remaining with 5 minus 10, 2 and 14. This is what you are getting. Now find out these values. Find out these all sums and everything. And let's tell me what it comes.
210.
210.
Yes.
Check it out. I will check out with my notes what it comes. Yeah, it's correct, no? So what we are getting, I just write down here. So 14, 6 and 96 plus minus 80, 16. So 112 plus this you will get 30 minus 20, that is nothing but 10 plus 14 5 are 70, 70 plus 20, 90, 100. It's comes something like that, no?
First element is 100.
First element
Yes,
is
sir.
100. 14 6 are 84. Okay,
And
yeah.
84 plus 16.
हाँ,
200
84
is
plus
coming.
84 plus 8 to the 16. So it's come 100. It becomes 200. No?
200. 200.
Yes, sir.
Yeah. So please check out the calculations. Huh? So it comes 200. Now find out determinant of A. Determinant of A. Find out. So we can directly find out here. So 5 into 14 6 are 84. We know that 84 plus 16 minus minus plus 10. So this row, this get cancelled. 6 to the 12. 12 plus 8. Again minus 5 in bracket. Am I correct? No. Minus 16.
Yes, sir.
Minus 16 and 14 4s are 56. So plus 56. So you are getting in 100 here 500. 20 plus 10. 20 into 10. 200 minus 5 into 56 minus 16. It becomes 40. 40 into 5. It becomes 200.
500 is the answer.
500
Yes.
is the answer. Correct. Correct. So this get cancelled. You will get 500 is nothing but your determinant of T. So you got all the values. So once you got all the values, then our characteristic polynomial. So characteristic polynomial becomes lambda cube. So this remains as it is. S1, the value of S1 is 25. So minus 25 lambda square. Again plus S2. S2 is nothing but 200. So plus 200 lambda and minus 500, which is equal to 0. Which is equal to 0. Everyone got this? Now you need to find the roots of that polynomial. For that purpose, you are allowed to use your calculator, scientific calculator, in examination also. Okay? Or you can find out by using another way. So you have another way also. What is that way? Do you know? First, write down the equation. It is called as synthetic division. You can calculate by using any other way. Yeah? So first is nothing but 1. First coefficient. So lambda square coefficient is minus 25. Then next one is 200. And here minus 500. So it goes, in terms of 5. It is divisible by 5, all the numbers. So let's check for the, you can take randomize starting from 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 3, like that. I can take here directly 5. Why 5? Because it comes in terms of, like that. It is divisible by 5 also, 10 also. You can take 5, 10 also. Just try. It is trial and error method. The synthetic division is trial and error method. It may happen 5 is the root. It may happen 5 is not a root. Okay. So we'll check with the 5 first. Because 1. So 1 into 5 here 5 comes. If I make an addition, it becomes minus 20. So minus 20 into 5. What it becomes? Minus 100. So if I do, I will get here 100 and here I will get 500. If lastly you will get 0, it means lambda is equal to 5 is my first root. And here how I write down this thing: first coefficient, second coefficient, third coefficient, fourth. Similarly, you can write down here, you will get lambda square minus 20 lambda plus 100, which is equal to 0. Lambda is equal to first root. Everyone understand that? Or you can use directly a calculator to find out the answer.
Understand the last part, sir.
How this one, no? Yeah.
Yes, sir. Yes, sir.
See, here what we have lambda cube, lambda square, lambda, and then lambda raised to 0, that is nothing but the 1. So I write down the coefficient in that way. First lambda cube, then lambda square, then lambda raised to 0. Now how many coefficients we have? Only 3 coefficients. It means we have degree 2. Here we have 4 coefficients. It means degree 3. So we start with the lambda square. So for 1 into lambda square, it is lambda square. Minus 20 into, I just remove less than degree, whatever we have here. So lambda, again the less degree, we have lambda raised to 0, that is nothing but 1. These are the coefficients of the equation. Okay.
Yes, sir. Yes.
So this is nothing but my first root. Your voice is breaking. Yes.
Sir, can you repeat once again?
Very okay. See, this is a synthetic division. Synthetic division means what? This is one kind of way to find the roots. Okay. So what I'm going to do, whatever I have equation, I can write down in an ascending order of its power. So let's see, lambda cube, lambda square, then lambda. Just see that lambda only. Yeah? Just see that lambda only here. See that only here, lambda cube, here lambda square, here we have lambda, and here nothing, lambda raised to 0. That is nothing but 1. So I am going to write down these roots. Here 1, here that 25, here 200. These are the coefficients of lambda cube power. I check with whether my 5 is root or not. So what I'm going, it is trial and error method. You can start 1, minus 1, 2, 3. If you will get last 0, then it is root. If you will get here 0, then it is root. So I will take first element as it is, as a down. So 1. I do the multiplication 5 into 1. I just write down here. And I then add this number 25 plus 20 minus 25 plus 5. I'm getting 20. Again I multiply 5 into 20. So I'm getting minus 100. I'm going to add this thing. So I'm getting 100 here plus 100. So again 5 into 100. I'm getting 500. If I add this minus 500 plus 500, it becomes 0. So when it becomes 0, it means that 5 is the root. So lambda is equal to 5 is my first root. And for my next root, again we have only 3 coefficients. See. So 3 coefficient, it means maximum degree is 2. So I will start with lambda square, then this coefficient into the next lambda plus 100 into lambda is 2, that is nothing but 1. Now got it?
Yes, sir.
Okay, now tell me what are the roots of that quadratic equation. This is lambda is equal to 5, first root, comma. You can write down here minus 10, lambda minus 10, which is equal to 0. Yes or no? Because you need to do the fractions, or find out the factors of 100. such that its addition becomes minus 20. So what you have here, minus 10 and minus 10. Minus 10 minus 10 is 100. The addition is minus 20. So lambda minus 100. So what are your roots? Your roots are lambda is equal to 5, comma 10, comma 10. These are nothing but your eigenvalues. Okay, and you can see what is sum of eigenvalues will give you. What is sum of eigenvalues?
Trace of a.
Trace. So what is our trace? Just check it out. Trace is nothing but a. You are getting 25. Sum is 10, 10 plus 5. You are getting 25. And what is product of eigenvalue will give?
Determinant of a.
So check it out. 10 into 10 into 5. 10 into 10 is 100. 100 into 5, 500. You are getting 500. So this is how you can cross check your eigenvalues. Okay, this is the one way to cross check whether these eigenvalues are correct or not. Everyone understand up to this? Or if you put these values in the calculator, you will directly get lambda is equal to 5, lambda is equal to 10, lambda is equal to 10 are eigenvalues. Okay. Any doubts, anyone up to this?
No, sir.
Okay. Okay. So what is my next problem now? Yes, please.
सिंथेटिक डिवीजन वाला नहीं समझ रहा
कौन सा वाला?
मैंने किया ना लैम्डा इक्वल्स टू 5 निकाला
ये वाला ना?
यस
Sir, where did 1 minus 20 and 100 came, sir?
One is nothing but the coefficient of lambda cube.
Yes, sir.
Lambda square coefficient is minus 25. Lambda coefficient is 100 and that constant is nothing but minus 500. So I just write down same here. So what is, if I wanted to write down this equation, so how one can write down? So lambda square coefficient is 1, so I write down here. Lambda coefficient is minus 20, I write down here. Then constant 100 like that only.
Sir, the 5 minus 100 and 500 came from dividing it by 5, sir.
No, that 5 you are talking about. Now how that 5 came?
The middle.
इंटरवल
The middle.
Here you are talking about, or here you are talking about. Here, no? See, for here, what we are doing, just give me a minute. Okay, I will erase that. See, first what I'm going to do, I just take my one number as it is below. Okay, that one comes as it is. Whatever the first coefficient, I take as it is. Then I do the product of that 5 and that 1. What is that product? That product is 5 only. So I write down 5 here. Okay, and then I add minus 25 plus 5. So minus 25 plus 5 is minus 20. So minus 20 came here. Then again I multiply that 5 into minus 20. So I do the product like that. I multiply here and put it here. Same thing. I multiply here and put it here. See, so 5 into minus 20, it becomes minus 100. Then I add, I will get 100. Then 100 into 5, again 500. Then plus or minus 500, it becomes 0. So if it becomes 0 here, lastly, then that lambda is equal to 5 is my first root. Okay.
yes
Okay. Well, I will share my one video on that also, or I will share one YouTube video how to find out the factors of cubic polynomial or cubic equation. Okay. So you will check it out. We just go within 5-10 minutes video is there. This is called a synthetic division. Okay. Okay. Then these are nothing but my eigenvalues. But my problem is not over. What is my problem? My problem is what? Find eigenvalues and eigenvector. You need to find the eigenvector corresponding to the smallest eigenvalue. So what is smallest eigenvalue here? Lambda is equal to 5. So to find, so our next target to find eigenvalues or eigenvector for lambda is equal to 5. That is what I have my task. So for that purpose, what you have for finding vector a minus lambda I operated on vector is equal to 0. This is my double star equation. For finding vector, this equation will work. Here A is nothing but your matrix. lambda is nothing but this 5, I is nothing but your identity matrix, and that X is nothing but your eigenvector, and that 0 is nothing but the matrix, 0 matrix, null matrix. So we substitute all the values. So tell me, what is A minus lambda I? Here I calculated A minus lambda I. See, A minus lambda I. Just you need to write down here, put the value of lambda, lambda, lambda. Lambda is equal to 5. So what you are getting? Please tell me, what is A minus lambda I? This matrix.
Sir, which value of lambda are we taking? 5 or
5,
10?
no, yeah. We are finding eigenvector corresponding to 5 only. For 10, we need to do the same calculation again. Okay, so right now we are taking for lambda is equal to 5 only. We are considering 5. Okay, so tell me, what is that matrix come? Value of A minus lambda. Lambda is nothing but 5. So all diagonal elements are 5. So subtract 5 from all diagonal elements and rest of the elements as it is.
0 minus 10
0
minus 5.
minus 10 minus 5. Very good. What is next?
292.
2, 9,
2
again 2. Okay.
minus 4 minus 8 1.
Minus 4 minus 8, 1. This is nothing but A minus lambda I. My X is nothing but my eigenvector. So I just write down here x1, x2, x3. Okay, if you have 3 by 3 matrix, you have 3 components of the vector. If you have 2 by 2, x1, x2 only there. And this is null matrix of. Now someone is saying, so how you decide this value and this value? Here we have product of two matrices. So when the product of two matrices will happen, so here we have 3 cross 3 matrix. So here to get equivalent product, we should have 1 here. So that 3 with equivalent, so we can do the product. And what is my resultant? 3 cross 1. So this is nothing but my 3 cross 1. So then and then only this equation is valid. If I take such values, then and then only. Okay. Got it? And it is a vector. We know that vector is nothing but either it is a row or either it is a column in the matrix. So it is vector, so I consider a column. Everyone understand this? What is this? Yes.
Sir, is if 3 cross 10, 3 cross 1 is not equal to 3 cross 1.
No. What I'm this is always valid because A is the square matrix and X is nothing but my vector, eigenvector. So eigenvector is what is meant by vector? Vector is nothing but either row or column in the matrices. So I'm going to write down that equation in terms of matrices. So that's why I write down here 0, 0, 0 is nothing but my null matrix, 3 cross 1. Because I know this one. What is this product? 3 here, 3 here. So 3 into 1. So 3 as to 1. You are getting like this. Okay.
So in general, I'm talking if it is not equal, then what should we do?
No. This is not the case only. That's why I'm talking about. If this is done, the product is not possible. The product is not possible. It means this equation is wrong. Okay. This is not. This is always there. This is why always there, because we are considering X is nothing but correspond. This is valid. Then and then only this comes. This equation itself is a valid equation. So it is always come. Always come. Okay. So you are saying, sir, what happened here? X1 and X2 only 2. This is not the case only. To make it this equation valid, you should have x1, x2, x3. If you have 3 by 3 matrix, if you have 4 by 4 matrix, then you have x1, x2, x3, x4. This is nothing but my vector. Got it?
Yes, thank you.
Okay. So now what? Tell me what it is.
Minus 10x2 minus 5x3 is equal to 0.
Or this is nothing but you can do the multiplication, no problem. You will get the answer. But in general, this is nothing but what?
Homogeneous equation.
System of homogeneous equation. Correct. How one can solve that system of homogeneous equation?
By finding
Augmented matrix.
Augmented matrix and find its
Rank.
rank. Exactly. So let's check it out. Let's try to find out augmented matrix. So everyone please write down with me also. So my first element should be non-zero. So I shift my R2 to R1. So I make a changes R2 interchange with R1. So what I will get 2920, and here I am getting 0 minus 10 minus 5 0, and then I will get here minus 4 minus 8 1 0. Now tell me, which operation should I use to make this element to be 0?
R2 plus 2
R3.
becomes R1.
R3 plus 2 into R1. Absolutely correct. So you are getting 2920. No need to change in R2, so I kept as it is. And here 0. If I use R2 and R1, here minus 4 and that plus 4, it becomes 0. Here minus 8 and plus 18. Am I correct? What is minus 8 plus 18?
10.
10. And here R3 is nothing but 1 minus plus 4. That is nothing but 5. Or 0 0 0. Tell me, what is next operation then now?
R3 plus R2.
Simply R3 plus R2. Very good. So once you do R3 plus R2, so what you are getting?
The rank of the matrix will become 2, sir.
2. Correct. So if rank is 2, how many solutions does that system have?
Infinite solution.
Infinite solution. And how many free variables?
1.
1 is nothing but the free variable. So you can find out now the values of x1, x2, x3. So you can find out here. So rank of augmented matrix is equal to rank of A, which is equal to 2, which is less than number of variables. Then free variables. Your free variables, number of variables minus rank, that is nothing but 1. So number of free variables. So now write down that system in the matrix form. So what is your matrix form? 2 9 2 0 minus 10 minus 5 0 0 0. That is nothing but my A matrix. My x1, x2, x3 is nothing but my second matrix, and 0 0 0 is nothing but my third matrix. If I do the product, so 2x1 plus 9x2 plus 2x3, which is equal to 0, and minus 10x2 minus 5x3, which is equal to 0. Now tell me, which value should I put as a free variable?
X2.
Is equal to 3.
X2, if I substitute t, you can substitute anything, no problem. X2 is equal to t. So x3 becomes plus 10t divided by minus. So we are getting minus 2t. Am I correct? Am I correct?
Yes, sir.
And now find out x1. X1 is nothing but it goes there 2 into x3. Minus 2 into x3 is nothing but minus 2t, and minus 9 into x2 is nothing but t, whole thing divided by 2. So what I am getting, minus 4t, it becomes 4t minus 90 divided by 2. So minus 5 divided by 2t. Am I correct?
Yes, sir.
Okay. So what is your vector then? Your vector is
Minus 5 by 2, minus 2 and 10.
x1, x2, x3. So you can calculate in another way. I will tell you how to calculate that. Minus 5 divided by 2t, x1, x2 is nothing but t, and x3 is nothing but minus 2t. You can take t as a common. So what you are getting, minus 5 divided by 2, then 1, then minus 2. Now you can put any value of t, any value of t. If I put, this is also correct. If I put t is equal to 2, because I don't want that rational number. So if I substitute t is equal to 2, what I am getting, that vector t multiplied by 2, I am getting here minus 5 2 minus 1. Is it okay?
Yes, sir.
You can substitute this also. Someone is saying, sir, I can substitute t is equal to 1. This is also correct. This is also correct. This is also eigenvector. This is also eigenvector for different t. But you don't mention to write down t is not equal to 0. Why t is not equal to 0?
सारा eigenvector कभी 0 नहीं है।
Yes, eigenvector never be 0. So for lambda is equal to 5, we have minus 5, comma 2, comma minus 4 eigenvector. Good. So write down up to this. Anyone, any doubts? Please clear your doubts.
No, sir.
Okay. Can I give you next problem? Okay. Now what happened? What happened? Here they are not asking. Okay. Here they are not asking anything. Okay. They are just asked find the corresponding eigenvector corresponding to the smallest eigen. That is what your end of the problem. That is what the end of your problem. But still here I have two eigenvalues. Okay, lambda is equal to 10 and lambda is equal to 10. It multiplicity is 2. Multiplicity is nothing but how many times that number is repeated. So here we have 2 times it is repeated. So I have just curiosity. What happened if eigen here for lambda is equal to 5, I will get one eigenvector. Now I wanted to check what happened when we have repeated eigenvalues. So here we have eigenvalues repeated 10, 10. So what happened with the eigenvector? Whether you will get two eigenvectors or whether you will get only single eigenvector. So for that curiosity purpose, we will solve this problem more further. Okay. In examination, if they ask find the eigenvalue corresponding the smallest one, you need to stop it here only for lambda is equal to 5. But for my curiosity, for our curiosity, we just check what happened when we have lambda is equal to 10. Is it okay, everyone? Can you understand what I'm trying to say?
Yes,
Yes,
sir.
sir.
Okay. So for lambda, let's find the eigenvector corresponding to lambda is equal to 10. So just everyone just do with me. So eigenvector corresponding to lambda is equal to 10. So here I have my value of lambda. Can someone tell me? A minus lambda I operated on x, which is equal to 0, my double star equation. So tell me what is A minus lambda I here? For lambda is equal to 10.
minus 5, minus 10, minus 5.
Minus 5, minus 10, minus 5. Okay, next.
2, 4, minus 2.
2, 4, minus 2.
Minus 4, minus 8, minus 4.
Minus 4, minus 8, minus 4. Here my x matrix is x1, x2, x3. And here 0, 0, 0. Now again I find augmented matrix. For augmented matrix, what I am getting? Minus 5, 10, minus 5, 2, 4, minus 2, minus 4.
Was it 2, 4, 2 or 2, 4, minus 2?
Here I will check it out. I will check it
Second
out.
row.
I will check it out.
2 for 2.
Oh, only 2 is there. No, only 2 is there. Yeah, only 2 is there. It's not -2. Yes. Good. Thank you. So rest of the things are correct now. Rest of the values.
Yes.
Okay. So now to make this element 0, this element 0. Now here we have -5, -10, -5. So it is divisible by 5 only. So you can directly divide, multiply 1 upon 5. Okay, or -1 upon 5. Okay. So what I'm going to do, I'm going to use first operation 1 -1 upon 5 into R1. This is valid operation. So if I multiply that, what I'm getting 1, 2, 1, 0. Next it's 2, 4, 2, 0 as it is, and -4, -8, -4, and 0 as it is. Someone is saying if I add, sir, if I subtract R1 and R3, it's okay. That you can apply also, no problem. If you multiply that 2 and may add here, you will get 1 here, no problem. You can do that also. You can use any operation. It doesn't matter. So now tell me what is operation I should use. So I will get 0 here.
R2 minus
R2
2
minus
times of
2 R1.
Correct. And
R3 plus 4 times of R1.
4 times of R1. Absolutely correct. So let's see. It is 1, it is 2, it is 1, it is 0, remains as it is. This becomes 0. R2 is nothing but what? You have 4. So 4 minus 4, this also becomes 0. Yes or no? And this also becomes 0. And this also becomes 0. Here, what happened? R3 plus 4, this becomes 0. This also becomes 0. This also becomes 0. This also becomes 0. Yes or no?
Yes, sir.
Check. So rank of augmented matrix is equal to rank of A is equal to 1, and which is less than number of variables. You have 3 variables. So what is number of free variables?
2. 2.
Correct. You can calculate by total variables 3 minus 1, that is nothing but 2. So if I write down that equation in our standard form, this from this, so my A matrix becomes 1, 2, 1, 0, 0, 0, 0, 0, 0, corresponding vector, and which also comes 0, 0, 0. So this implies what you are getting, x1 plus 2x2 plus x3, which is equal to 0. Now we have 2 free variables. So you can put x1 is equal to, suppose, m, and x3 is equal to n. You can put anything. This implies what you are getting, your x2 is equal to minus m minus n divided by 2. Am I correct? Check it out.
Yes, sir.
Now the important task comes here. How my vector look like now? What we have x1 here, x2 and x3. So if I substitute these values, so what I'm getting, x1 is nothing but m, I can substitute. X2 is nothing but minus m minus n divided by 2, and x3 is nothing but n. So I can take m first common out here. So what I remaining with here, 1 minus 1 by 2, 0, and plus n. Please tell me whether you understand that or not. Whether you understand that, how I written this
Yes,
thing.
sir.
Yes, sir.
Okay, what I did, I take m common out. So what are the coefficient of m remains here? 1. Here coefficient is minus 1 by 2. Here coefficient is nothing. That is nothing but 0. I take n common out. Here coefficient is 0. Here minus 1 by 2. If I add that two equations, I will get this equation. Okay.
Yes,
So
sir.
now you can put m is equal to 2 and n is equal to 2 or 4 or any number, because where you can write down here m and n not equal to 0. Because it becomes 0, so I'm getting 0, 0 vector, and eigenvector never be 0. So what happened here? If I put, if you put or if you don't put, doesn't matter. So for simplicity purpose, if I put, what I'm getting my eigenvector 1, oh sorry, 2. M is equal to 2, it means you have to multiply inside. So 2 minus 1 0, and what I am getting here 0 minus 1 1. So these two are eigenvector corresponding to lambda is equal to 10. This and this. Okay. Are you getting my point?
Yes, sir.
Okay. So you can write down for lambda is equal to 10. For lambda is equal to 10. For lambda is equal to 10. We get two eigenvector. First one is what? 2 minus 1 0 and 0 minus 1 and 1. Oh sorry, not 1 here, 2. No, if you multiply by 2 it comes 2 here. So sorry, 2, like that. Okay. Or you can directly write down, if m is equal to 1, which is equal to n, so you will get like that only. 1 minus half 0 and 0 minus half 1. No problem. This is also correct. This is also correct. So see, sometimes it's total, sometimes for single eigenvalue you have corresponding to eigenvectors. Okay. And sometimes for single eigenvalue you have single eigenvector. Okay. Now someone is saying, sir, whether it is just because of lambda is equal to 10, because eigenvalues are repeated here. Someone is saying, sir, whether this is the case, my eigenvalues are repeated here. That's why my eigenvector, I will get two eigenvectors. So this is not the necessary. So in the next lecture or while solving the problem, you will get a problem like that only. For even if my eigenvalues are repeated, still you will get sometimes only one eigenvector. Okay, clean and clear? Whether everyone understand eigenvalues
Yes.
and eigenvector?
Yes, sir.
Okay, so I'm going to give you one example as a homework. Try to solve this example, and also we have lots of example in question bank also. Okay, so try to solve that example also. So homework example. Find eigenvalues and eigenvector for 0, 4, minus 1, 4, again -1, -2, 5, -1. This is the first one. Second one, your matrix is 0, 1, 1, 1, 0, 1, 1, 1, 0. And third one, 1, -1, 1, 1, -1, -1, -1, -1, -1. Okay. Try to find out eigenvalues and eigenvectors.
Sir, what is 831 for first question?
What?
First question, 3 1 element.
3, 1, -2. Third row, first column you are talking about, no?
Yes, sir.
It is -2. -2, 5, -1.
Sir, is yesterday class uploaded on YouTube, sir?
Yes.
Sir, by what name?
Only my link is there, so I will share the link one more time with you. Okay.
Okay.
So eigenvalues and eigenvector. You are talking about the name of the video, no?
Yes, sir. Any-
Eigenvalues and eigenvectors.
Okay, sir. Okay, sir. Thank you, sir.
Thank you. So this is what we have for the today's lecture. Anyone, any doubts?